Problem 2. As a pot of tea cools, the temperature of the tea is modeled by a differentiable function h for 0 to 10, where time t is measured in minutes and temperature h is measured in degrees Celsius. Values of h are at selected values of time t are shown in the table above. Alrighty. Part A. Use the data in the table to approximate the rate at which the temperature of the tea is changing at time t equals 3.5. Show the computations that lead to your answer. Okay, it says find the rate at which the temperature of the tea is changing. The temperature of the tea is h, so if I'm finding the rate of change of the temperature, I'm actually looking for h prime, and I'm trying to find it at 3.5. Okay, I noticed that 3.5 would be somewhere between the 2 and the 5, so I'm going to actually use these values to help me find the derivative or the slope. So I'm going to be doing y2 minus y1 over x2 minus x1. That will give me 52 minus 60 over 5 minus 2. That gives me negative 8 over 3. And I could leave it as negative 8 over 3, or if I wanted to write it as a decimal, that would be negative 2.667. And my units on this one would be degrees Celsius per minute. All right, that was worth, unfortunately, only 1 point. All right, but please make sure you do show your computations. All right, part B. Using correct units, explain the meaning of 1/10, the integral from 0 to t, of h of t in the context of this problem, and then use a trapezoidal sum with 4 subintervals indicated by the table to actually estimate that value. Okay, as soon as I see the 1/10, I know where it looks like set up a problem 1 over b minus a, the integral from a to b. So I know it's talking about the average of something, and then I look right here inside to see what they're finding the average of. So it's going to be the average h, so it's going to be the average temperature of the tea. So this is the average temperature, and I'm going to put in degrees Celsius of the tea, and I do need to mention when, from t equals 0 to 10 minutes. Okay, that is worth 1 point to say that. A couple things we do need to make sure. We say that it's an average temperature, we say what the units of that are, and that it was over that time period. Okay, the next thing was to actually use the trapezoidal sum, and I would really like to use the trapezoidal rule, but I do notice in these 4 subintervals they are not going by equal amounts. So I'm going to have to actually do 4 separate trapezoids to get this answer. Okay, and the area of a trapezoid, if you recall, is 1/2 height times the sum of the bases. So this is the formula that I'm going to use. I'm going to use that formula 4 different times. Okay, for my first interval, I'm going to have 1/2. The height of this trapezoid is just going to be the distance between these first two, which is 2. And then the bases are going to be 66 plus 60. And then plus 1/2. This next interval goes from 2 to 5, so its height will be 3. And the sum of its bases will be 60 plus 52. And then plus we'll have 1/2. The height on this next one from 5 to 9 will be 4. And the sum of its bases will be 52 plus 44. And then plus the last one will have 1/2. The height will be 1. And the sum of its bases will be 44 plus 43. All right, and then when we do that, if I come up, and then don't forget, after I've done that, I do have to multiply by 1/10 because it did ask me to find 1/10 times the integral. So if I do all of that stuff, I should end up getting 52.95, and since this was an average temperature, it would be degrees Celsius. All right, that was worth 2 points for this part. If you set up the problem using a trapezoidal sum, you'd get 1 point, and then if you got the right answer, give yourself another point. All right, part C. Evaluate the integral of from 0 to 10 of h prime. Using correct units, explain the meaning of the expression in the context of this problem. Okay, so they're asking me to take the integral of a derivative. The integral of a derivative, they just cancel each other out, so I'm just going to be left with h, and then remember we do have to evaluate it at our endpoint, so we're actually going to have h of 10 minus h of 0. And I can actually just look these up on my chart. H of 10 is 43, h of 0 is 66, and that is going to give me a negative 23. and then it says to explain what that is in the context of this problem. Again, if we're looking at H, this is going to have to do with temperature, and I can tell since I got a negative 23, that must have been from time 0 equals to 10, the temperature of the T dropped 23 degrees Celsius. So I'm going to say the temperature of the T over the 10 minutes dropped 23 degrees Celsius. And you could have worded it a little bit differently, but you should have the same kind of idea with that. Alrighty, that was worth 2 points. 1 point for the correct value, the negative 23, and then 1 point for the correct meaning. Alright, part D. At time t equals 0, biscuits with temperature 100 degrees were removed from an oven. The temperature of the biscuits at time t is modeled by this differentiable function. B prime is equal to that nice formula. Using the given models at time t equals 10, how much cooler are the biscuits than the tea? Well, to figure out how much cooler the biscuits are than the tea, I need to know what's the temperature of the biscuits at time 10, and then what's the temperature of the tea at time 10. So those are the two things, and we will subtract them. All right, to get the temperature at time 10, I notice we're going to start at 0 and we're going to go up to 10, and I'm given b prime. So if I'm at b prime, to get b, I know I'm going to take the integral, so it's going to be the integral of b prime. I'm going to go from 0 to 10. Okay, couple different ways that you could do this. If you do that, the integral from 0 to 10 of b prime, we could definitely use Math 9 to get our answer for that one. And when we do that, we are going to get, hold on, this is another one I've got to get my calculator out for. Okay, when we use our calculator to get that answer, we will get negative 65.817, I believe. All right, so basically that's telling me how much the biscuits have cooled. They did start out at 100, so I'm going to do 100 minus 65.817. So the temperature of the biscuits at time equals 10 should be 34.183. So that's the temperature of the biscuits. So basically now I'm just going to do b of 10 minus h of 10. So it's going to be the temperature of the biscuits minus the temperature of the tea. And the temperature of the tea we could get right here was 43. And actually I should have that the other way around because I want to know how much cooler are the biscuits than the tea. So if I subtract those two and take the absolute value or whatever you want to do, we should get 8.817 degrees Celsius. So the biscuits are 8.81 degrees Celsius cooler than the tea. That was worth 3 points. If you set up an integral right here to show that you needed to find the integral of b prime to get the temperature of the biscuits, give yourself 1 point. If you used this 100 to actually get the temperature of the biscuits, give yourself a point. And then if you were able to find the 8.817 degrees Celsius, give yourself another point.